In this video, we're going to work on finding the solutions to a quadratic or polynomial equation by graphing. The first step in doing that is to set your equation equal to 0. We have 2x squared equals 20x, so I'm just going to bring that 20x over to one side, set it equal to 0. This one's already been set equal to 0. Let's take a look at the next one down here. We have 4x equals x squared plus 3. So let's bring that 4x over. And I'm going to write these in descending order of exponents. So that will give me 0 is equal to x squared minus 4x plus 3. And then this last one here, x to the third minus 3x squared minus 198x plus 1080 equals 0. So we want to find out when all of these polynomials are equal to 0. So we're finding the zeros of these polynomials. That happens when the function crosses the x-axis. So that's where your zeros happen. And so what we're going to do is we're going to use our calculator, turn it on, go to y equals, and type in y equals 2x squared minus 20x. Hit enter. Now, go ahead and graph this. Notice I'm in the standard window. This did not show me very much of the graph, and so I'm going to zoom out. That helped. So I can see that my parabola is going to be mostly in the first quadrant, but it goes quite low and it's too far down here. So I'm going to change my window and I'm going to say my x values go from a minimum of, say, -5 to a max of maybe 20. And then I'm going to make my y values show further down. So I'm going to say maybe to -70. I'm just guessing here. And my y max doesn't need to be quite at 40. We can do 20 instead and see what that does to my graph. Notice that this shows me a nice space of a quadratic or parabola shape. And so now we need to figure out where those zeros are. Well, I could do that over here on the equation. I could have factored out a 2x, and I could see that it's x minus 10 equals 0. So I know that my solutions are x equals 0 and x equals 10. I know that, and sometimes this process is faster. And in this case it would be, but for the process of showing the steps on a simpler question, I'm going to show you how you can find the zeros of this polynomial. Do second, trace. Arrow down to zeros, hit enter, and now it's prompting you for a left bound. Now this is the left bound on the x-axis, and this little blinking cursor here is not on the left side of the intersection with the x-axis. So I'm going to arrow to the left until I pass the intersection. Now notice that my y values, my outputs, are going to get closer and closer to 0. And then they cross to positive. That's when I know that I've passed the intersection point, when it changes in the y values, the outputs, from one sign to the other. So I hit enter, and now I'm going to arrow to the right because it wants the right bound. Notice again it changed from one sign to the other in the outputs, in the y's, in the range. And then it wants you to guess where the intersection is, and so you just arrow as close to the intersection as you can see and hit enter a third time. And that is indeed one of my zeros. I have a 0 of my polynomial at 0, 0. Now we'll do that same thing again on the other intersection point. So we do second, calc, arrow down to 0, enter. We want the left bound. Enter. Now we want the right bound, enter. Now we want to guess, enter. And we have x equals 10, y equals 0. So these are the two zeros of this first polynomial. Now let's graph x squared minus 4x plus 3. Go ahead and clear what you have in your y equals. Type in x squared minus 4x plus 3. Graph it. And notice this one looks to be a lot more shallow than what we had originally. So we will need to change our window. We'll make our y min and our y max go somewhere close to what we would normally have as a standard window. So let's just do zoom standard. And this has a nice parabola where we can see that it looks like our intersections are at 1 and 3. If we check that without even using the zeros, because in this case it might actually be easier to just check it with binomial factors. If you have x and 3 and 1, and they're both negative, will that give you x squared minus 4x plus 3? Well, x squared minus 1x minus 3x plus 3, that will indeed come out to be what we started with. So we can just look at the graph sometimes without even using the zeros calculation to get our solutions. So the two solutions are x equals 3 and x equals 1. Now let's look at C. Take your calculator, go to y equals, clear any equations in there, type in x cubed minus 3x squared plus 5x, and then graph it. It appears that there is only one real solution to this cubic, and it appears to be at 0. Let's factor out the common factor x. This will give us x squared minus 3x plus 5. If we were to try and graph just this factor here, we would see that this does not have any real roots. Therefore, the only solution to C is x equals 0. And let's take a look at this last example. We have x to the third minus 3x squared minus 198x plus 1080. We're going to go to y equals in our calculator, clear our entries, and then type this equation in. Graph it and see what we come up with. Let's see if zoom fit will help us with this, because this looks like a very large scale graph and we're only seeing one line. So let's go to window. Yes, we're in standard windows, so let's go to zoom. I wonder if zoom fit would work. Notice that it's only showing me a little piece of this graph. I want to see what's happening on the left and the right side. So I'm going to go back to my window, and I'm going to make my x min be -20 and my x max be +20, and just see what that does to my graph. Since I know that my polynomial is of degree 3, then I know that the maximum number of solutions I could have is 3. And so I can see all 3 intersections with the x-axis, to the left of 0 and then 2 to the right of 0. So now it's just a process of going to second calc, going to zeros, selecting 0, and then going through the whole process of going to the left of the intersection point, which can be a little bit tedious, to the right of the intersection point, and then guessing. So you can see that one of my solutions is -15, 0. Now let's try the next 0. We want a left bound, so hit enter, a right bound, hit enter, guess, enter, and we have 6 as another root, or 0. And then the last one is here on the far right. Helps if I push 0. There we go. To the left of the intersection, to the right of the intersection, as close to the intersection as we can get. And our last root, or 0, is at x equals 12. And this is how you can solve these with your calculator.